All right.
Yeah, if it's your favorite, if you're gone for a day, do you have to make it up, or do they just throw that day away?
We don't know. So yes, the first part that we talk about, most of what we talk about today, will go in your graphic organizer. And we're combining, this is 6.2 and 6.4. We're going to talk about special quadrilaterals. So most of the information, it's nice because we can fit the descriptions, the important information about the quadrilaterals inside the little shape of the quadrilateral. So the way this graphic organizer is arranged, all of the shapes on the graphic organizer, it's like a family tree. All of the shapes on the graphic organizer are quadrilaterals. Quadrilateral is the big family. That's the main family. And then if it's connected by an arrow, that means it's related to that thing that it's connected to, and it shares all the properties of the thing that is connected to. So that's how our graphic organizer works. So first off, let's look over to the left, and we'll talk about a trapezoid. So you can see on your graphic organizer that a trapezoid is a quadrilateral. What do we mean by quadrilateral? Four sides. Four-sided shape. What is special about a trapezoid, and you can put this inside, only one pair of parallel sides. So your picture, we can mark our picture. The picture looks kind of like this. And that would be our pair of parallel sides. So that's what makes a trapezoid special. It has one pair of parallel sides. And we'll talk about isosceles trapezoids later in the chapter. All right, so let's go to the middle. Parallelograms. So a parallelogram is a quadrilateral. And a parallelogram, this could go inside, has two pairs of parallel sides. So the picture of our parallelogram looks something like this. So these two sides would be parallel. And remember, parallel we mark with arrows, and those sides would be parallel. So you could draw that onto your figure. And this makes several special things happen. That's why we call them special quadrilaterals. In a parallelogram, opposite sides are congruent. So these two sides, not only would they be parallel, but they are congruent. Opposite angles are congruent. So this angle, if you wanted to mark that in your parallelogram, that angle is congruent to that angle. And this angle is congruent to that angle. So opposite angles are congruent. The diagonals bisect each other. And what do we mean by diagonal? How would we draw a diagonal? From one vertex to the opposite vertex. So across the middle. So a diagonal. And bisect means they do what? Cut each other in half. So if we drew two diagonals, we can't really draw two diagonals because we're writing stuff in there. If we draw two diagonals, right where they would meet would be right in the middle of each of the diagonals. The diagonals bisect each other. Consecutive angles are supplementary. What do we mean by consecutive? What if I said, what if I was talking about consecutive days of the week? Adjacent. One right after the next. Consecutive angles means two angles in a row along any side. Those two angles would be supplementary. Those two would be supplementary. Those two are supplementary. Those two are supplementary. Supplementary means they do what? Add to 180. So all of those things are true about parallelograms. Two pairs of parallel sides, opposite sides congruent, opposite angles congruent, the diagonals bisect each other, and consecutive angles are supplementary. All right, questions on parallelograms? All right, let's move over to the right to a rhombus. So notice, based on our family tree, our graphic organizer there, a rhombus is a quadrilateral because it's on the graphic organizer, four sides. It's a parallelogram because we've got an arrow coming from the parallelogram. Another thing that makes a rhombus special is it has four congruent sides. So your rhombus looks like so. A lot of times we think of a rhombus as a diamond. And all of the sides of our rhombus are congruent. Another thing that makes a rhombus special, it's still a parallelogram. So it has all of the properties of a parallelogram. But a couple of other important things. The diagonals are perpendicular. And what does perpendicular mean? They intersect at a 90-degree angle. So if we drew the diagonals, they would meet at a 90-degree angle. And the diagonals bisect the angles. So if I drew in a diagonal here, it cuts the angles of the rhombus in half. The diagonals bisect the angles. So a rhombus has all the properties of a parallelogram, plus the diagonals are perpendicular and the diagonals bisect the angles. All right, we good there with a rhombus? All right, let's go to the left, to the rectangle. So we're still talking about a quadrilateral. Rectangle is still a parallelogram, but it has four right angles. So we're getting more and more specific as we go down the graphic organizer. So a rectangle looks like so. and all of these are right angles. A rectangle is a parallelogram. And the diagonals are congruent. The rectangle has all the properties of a parallelogram. It has 4 right angles, and the diagonals are congruent. Diagonal goes from, let's draw a picture here just so everybody's clear. Diagonal is from corner to corner. So if you want to draw a little sketch in there on the side, just so you know, make sure. Diagonal goes from corner to corner. All right, we good on a rectangle? All right, the last one is a square. So notice that the square, it is connected to both the rectangle and the rhombus, and each of those is a parallelogram, so a square has all of those properties of the things above it, plus some more. So square has 4 congruent sides, 4 right angles. And that makes lots of special things happen with a square. Miss Voss told me she tells her students that a square has a father that's a rectangle and a mother that's a rhombus. And I told her that kind of freaked me out. Just a weird way to describe it, I thought. Something to think about that. Miss Voss said that from your graphic organizer, a square is a shape that has a father that's a rectangle and a mother that's a rhombus. To me, that's right. All right, so square has 4 congruent sides, 4 right angles. It is a parallelogram. It is a rectangle and a rhombus. So it has all of the properties of all of those things. So the diagonals bisect each other. Because it is a parallelogram. They are congruent because it's a rectangle, and perpendicular because it's a rhombus. So you'll get some interesting questions about how to classify shapes, like, can a rhombus be a rectangle? Can a rhombus be a rectangle?
No.
Can a rectangle have all the sides equal? No? A square is a rectangle? But I said, so can a rhombus be a rectangle? So when would a rhombus be a rectangle? When it is a square. So rhombus would be a rectangle when it's a square. So those are the kinds of questions that you get to think about with this. All right, so we will do the kite and the isosceles trapezoid on the graphic organizer later. What I want to do now is we have one additional theorem that we need to talk about, and then I want to do some examples using these ideas. So the rest of the stuff you might be able to put on the back of your graphic organizer, but I would suggest you put it in your notes. And then we'll do some examples. But hold on to your graphic organizer. It will definitely help you with your homework. We're doing 2 sections today. That's why we end up with 2 sections of homework. All right, so our theorem. We combined 6.2 and 6.4 because it made sense to talk about all those things together. Our theorem: if 3 or more parallel lines cut a transversal in congruent segments, then they cut congruent segments on every transversal. So if we draw the picture, this should make sense. It's not a difficult concept. So here are 3 parallel lines. So I'm going to say I'm going to call those points A, B, C, D, and E, F, where all these meet, and we're saying that AB, line AB, is parallel to line CD, and is parallel to line EF. And AC is congruent to EC. So we have these 3 parallel lines, and they're cutting this segment into congruent segments. This line into congruent segments. Then it cuts any transversal, they cut any transversal into congruent segments. Then BD is congruent to DF. And the idea here is that the parallel lines are always the same distance apart. So if these 2 segments are congruent, the parallel lines are the same distance apart along this segment, they're going to be the same distance apart along this segment also. So that's what this is telling us. And we'll use this when we talk about trapezoids and some other ideas with special quadrilaterals a little later. All right, questions? Okay, let's look at some examples. All right, we good? Okay. All right. In your book, In your book, they use the symbol. They draw a little parallelogram symbol, and they'll say RSTU. This is the symbol that your book uses for parallelogram. So it looks like the symbol we use for plane. They use the word plane, the word P-L-A-N-E for a plane, and they use this symbol for a parallelogram. So if you see a picture that looks like this, and in these, we really need to be careful from here on out to go by what the diagram tells us, not by what it looks like. R-S-T-U. This would tell you that this is a parallelogram. And you know that this angle is 71 degrees. And the problem tells you to find the measure of angle R. What would we do here? 180 minus 71. Because this is a parallelogram, consecutive angles are supplementary. So we know that measure of angle R plus 71 equals 180. So the measure of angle R equals 180 minus 71, which gives me 109 degrees. What would measure of angle S be? 71. What would measure of angle T be? 109. So in a parallelogram, you only have two angle measures. It's one or its supplement. Angle measure or its supplement. Makes them kind of nice. Questions on that example? All right. Little more complicated example now. So this is parallelogram HKJI. And I'm going to draw in the diagonals now. Well, what do we know, first off, before we even set up the problem, what do you know about the diagonals of a parallelogram? They do what? Bisect each other. So this piece is A, and this is 2B minus 8. What do we know about those two pieces? They're congruent, they're the same. And if this is A plus 2, and this is B, what do we know about those two pieces? They're congruent, they're the same. So if we said, if the problem asks us to find A and B, we know that A equals 2B minus 8. This point is right in the middle, so these two pieces are the same. And we know that B equals A plus 2. These two have to be the same, since this is a parallelogram. What do we do here to find A and B? Combine the equations. So when we have two equations with two variables, we say our first step is to get one variable by itself in one equation, and then substitute it in, right? Well, this equation says A equals 2B minus 8. I'm going to take that and put it right there for A. So B equals 2B minus 8 plus 2. So B equals 2B minus 8 plus 2 is minus 6. Subtract 2B from both sides. So negative B equals negative 6. And so B equals 6. Now we have b equals 6. And I'm going to take this and put it right there. Substitute it into the other equation. So 6 equals a plus 2, so minus 2, and a equals 4. A equals 4, b equals 6. Now we can check to make sure we did it right. If b is 6, a plus 2 is 6, and they equal each other. So we're good. All right, questions there? Okay, let's look at another one. All right, here is my setup for this one. All right, first off, before I set anything else up here, what kind of shape is this? Trapezoid. We have one pair of parallel sides. We have trapezoids kind of stacked on top of each other, actually. All right, I'm going to say this is 5, this is 5, and this is 7. And we want to figure out what WU equals. So we're looking for that whole side. Well, here we have 3 parallel segments, and these 2 are congruent. So what does that tell us about these 2? They're congruent. That was what our theorem said. So if this side is 7, what's this whole thing? 14, so WU equals 14. That one was easy. All right, last example. All right, so I'm going to say this is a rhombus. And we want to find measure of angle 1, measure of angle 2, and measure of angle 3. Let's do the easy one first. Measure of angle 1. If this is a rhombus. 100, right? Rhombuses are parallelograms, opposite angles are congruent. If this angle is 100, what are angle 2 and 3 together? So these 2 are, the consecutive angles are supplementary. So together they're 80 degrees. So what does each one have to be? 40. Because the diagonals of a rhombus bisect the angles. So measure of angle 2 equals a measure of angle 3 equals 40. All right, we good there? Okay. Homework. All right, there we go.